Welcome to Proving Inverses. Let's go ahead and get started. So here's the essential question we want to answer today. How can we prove that two functions are inverses of each other? So the answer is that we use composition to determine whether two functions are inverses of each other. So in this case, I have a function, and then I have its inverse, or what I'm saying the inverse is. And what you do is you plug f of x, I'm going to plug this into the x of this inverse. So that's using composition. And I'm going to simplify. And then I'm going to go the other way, and I'm going to plug the inverse into the x of the original function and simplify. So I'm still doing composition, but I'm going to do it twice. So let's go ahead and do that in this example. So I'm first plugging the original function into the x of the inverse. So I would have that saying that the inverse, so that's the inverse with the function inside because I'm plugging that function in the inverse, which is 3/2, and now I'm plugging this in, 2/3 x plus 2, and then minus 3. So again, here's the inverse, and we plugged f of x into here, okay? So we started with the original, plugged it into the inverse, now we're simplifying. So 3/2 times 2/3, that's just 1, so we just end up with 1x. And then 3/2 times 2 is just 3. And then we have this minus 3 at the end, so my answer is x. Okay, so now we want to go the other way. That was the first step, now we want to do the second. Now we want to plug the inverse into the x here, so just using that composition again. So we're having f of negative 1x. Okay, and sometimes there'll be f and a g or g and an h, just saying they're inverses. But in this case, we're saying that this function already has an inverse, and we just want to prove it. Okay, so plug the inverse into the x here. That's a 2. And then we're going to plug in that inverse. And we still have this plus 2 here. All right, then we distribute, we're simplifying this. We just end up with x minus 2 plus 2, and that ends up being just x. Okay, so this is the part that you have to remember. We did the steps, we plugged one into the other, and then we did the other way. Now both of our answers are x, so that means they are inverses. Okay, so we just proved that both functions are inverses of each other. Okay, so if this was x plus 4 and this was x, then they're not inverses. Or if this was 2x plus 1 and this was 2x plus 1, they're not inverses. The rule is that they both have to be x. Not just that they have to be the same, but they both have to be x. Alright, so here's an example for you to try on your own, okay? Is this function f of x and g of x, are they inverses of each other? So plug one in for the other, and it doesn't matter which one goes first. You can start plugging that in and then go the other way, okay? But you want to find f of g of x, so you're plugging one in for the other, and you want to find g of f of x. And remember, they should both end up as x in order for them to be inverses of each other. So just pause the video and then come back and check to see if you did okay. Alright, so hopefully you took some time to see if you could compose these two functions together to prove if they're inverses, and you should have found that they're not inverses of each other. So let me show you how that works. So we found f of g of x first. That means we're plugging the g into the x of the f first. And so that would give me 3 1/3 x plus 8 minus 8. Okay, so when I distribute this, it should give me x plus 24 minus 8. And that ends up as x plus 16. Okay, so right away we should know that these are not inverses because remember they both have to be x. But just in case, you always want to try the other one because there is a chance you could have made a mistake. So now g of f of x, we plug that f into the x of the g. So 1/3, that's a 3, and then 3x minus 8 plus 8. Alright, so if you distribute this, you end up with x minus 8/3 plus 8. Okay, so we know that that's not, neither one of these are going to be inverses of each other. This didn't end up as x, this didn't end up as x, so these are not inverses. So don't forget that rule that they both have to equal x. They don't have to be the same, they both have to equal x in order for them to be proved as inverses. Alright, so don't forget to write your questions in your summary. Remember that your summary should answer that essential question, how do we prove that two functions are inverses of each other? And that's all for now. Thanks for watching. See you soon.